Okay, good afternoon, ladies and gentlemen. As we can see, it's exactly 2 p.m. on this watch on the wall. So, welcome to this afternoon session. It's the last parallel session before the closing session, which starts immediately after this one at 3:30, and there will be no break. So we will try to finish maybe a few minutes before so that we all can go to the closing panel session. We are continuing with this topic, Inspire in the cloud and online platforms. So there was one session already before today. So this is some kind of continuation. So I hope that we will again have nice presentations. We have 5 speakers, so we will not waste our time. I would ask first of our speakers, Rope, to take the floor and start with the presentation, please.
So, good afternoon, everyone, and thank you for introduction. My name is Roope Tervo. I come from Finnish Meteorological Institute, and I'm going to tell you a story about our open data distribution on Amazon's cloud service. FMI opened its data in 2013, and back then, basically everything that FMI has property rights to open was opened. The data content is quite vast. We have a number of different types of datasets there. There are observations, real-time observations, historical observations, climatological data, weather forecast models, marine forecast models, and so on. And all the data is provided freely in machine-readable formats. And actually, all the data is, or practically all the data is provided in Inspire harmonized formats. Our FMI Open Data Portal follows Inspire requirements, and actually we had the very same data portal working as an Open Data Portal and for Inspire services. We do require a registration in order to use view and download services. Working email is a mandatory information, and after registration, user gets an API key, which had to be added into all requests. This is not very convenient for open data users, but it helps us to gather some statistics and prevent misusage of the data portal. And we actually have some usage limits in the data portal. With one API key, one can do at most 20,000 requests per day to download service, which means that with one API key, you can download everything which is released there once. But our data portal is not meant to be as a backend for any clients. It's for data exchange, like Inspire also is. Our open data portal has been open for 4 years now. We are doing quite good. At the moment, we have almost 12,000 registered users, and we got a little over 800,000 data downloads per day, almost 10 requests per second. But this is not enough, because the data is valuable only when it's used, when it's reached relevant audience. And maximum coverage requires several different channels and services. Different kind of services and channels are for different users. Different services are actually more convenient. And because of this, FMI and Amazon started a pilot, and FMI joins Amazon's public datasets. In practice, that means that some of our open data is also distributed in Amazon S3 cloud platform. This is a 2-year pilot. It started in May 2017, so 3 months ago. And in the first stage, there are available our weather forecast model. One more slide about the content next. Our main objective is to increase the utility and effective use of our data. This distribution is especially convenient for that kind of users who need to do some post-processing for the data, or maybe generate some map visualizations, or practically anyone who needs all the data for themselves. The content: weather forecast model, Hirlam weather forecast model, surface and pressure levels, so means ground level and upper air, covering Europe, updates 4 times a day, 2 days ahead, and there's archive kept during the pilot. The whole one model output is something 25 gigabytes large, so it's quite a large amount of data updating every 6 hours. In practice, this means that the data is uploaded to 2 S3 buckets. There's one for surface data and one for pressure level data. So the user can access the data via S3 protocol directly, or user can browse bucket content with a web browser and download data manually. And then there's also available some notification service topics which can be subscribed, so that whenever new data is added to the S3, user gets a notification and he can start processing, downloading and processing the data. And one thing I forgot to mention, this channel is very especially convenient for users who's using Amazon's web services, because they don't have to download the data off the cloud, and all data transfers inside the cloud are very fast. So it's very easy for them to fetch the data for processing. There's a link to the documentation. So we have been, and the pilot have been going on for 3 months now. How well has it succeeded? In this chart, there's some data requests divided by the data format and data model. FMI provides the same data in different formats and different models. And this chart is about FMI Open Data Portal, not S3. 2 columns on the right side are Inspire data formats, grid series observations and point time series observations. Then there's simple feature column, and the invisible left column is for binary gridded data, binary data formats. So from here you can see that Inspire data formats are the most popular one, and point data requests are by far the most popular type of requests. But still, during 1 month, we got almost 40,000 binary data requests, which is quite significant amount of requests. And these are large requests. These are something like 20 gigabytes per request, so they are heavy requests. If you look those requests more deeply, this chart is the Hirlam weather forecast model download requests in binary formats divided by channel. So on left side there's FMI Open Data Portal, and on right side there's Amazon S3 bucket. The blue column stands for raw requests. So you can see that Amazon S3 gets a lots more requests than our Open Data Portal. But the data in the Amazon S3 is divided in so that all the parameters, different parameters, are in different different files, so that temperature forecast is one file and precipitation forecast is other file and so on. So if user wants to download the whole model output, she needs to do many requests to Amazon S3. And from FMI Open Data Portal, one can download everything with one request. If we assume that all the Amazon S3 users download whole model output, we can scale the request so that these channels can be compared. The result is in red column, and from there we can see that Amazon S3 gets about 30,000 requests more than FMI Open Data Portal. So, for binary data downloaders, users who post-process the data or visualize it via maps or that kind of people, S3 is already the most popular channel, and the pilot has been going on for 3 months. So it's looking very promising. But still, Inspire data formats and point requests are by far the most popular type. Anyway, this pilot is very promising, and I think, and I hope we can continue this after this 2 years pilot phase. It looks like it. Finally, there's one application, one slide shown yesterday in Dublin. Meteor Group has found our pilot and has done some sample application during one weekend, practically with no cost. And we have no connection with Meteor Group. This is just coincidence. I'm very happy about that. Okay, that's all. I was fast.
Thank you, Rob. So, I think we can open the floor for the question, if there is a. It seems not. Then maybe I will take a right as a chairman. I'm interested, who are the users of your services? Do you have an overview? Who is mostly using your data? Who is downloading?
We don't know very accurately because still it's open data, and only information we have is some email address. But we do know many companies, both Finnish and international companies who are using. We know about 17% of the users who have, we had a survey about our users, and 17% of our users who answered to survey was from researchers. I think it was something like 30% was private developers, and the rest was companies. So.
Thanks. Good. Okay, any other question? It seems not. Okay, thank you, Rob, once again.
Okay.
And since Rob has to leave us, I think, so have a safe trip home.
Thank you.
Yeah, bye. Okay, so we move to the next presentation. Will be given by my colleague from GRC, Peter Strobel. So Peter, please, the floor is yours.
They are very good in putting that in a different place in each release. Okay. Good afternoon, everyone. Thanks, Vlado. What I'm going to talk about is a specific aspect of Inspire that is very often, that is not or was not very often highlighted in the past, and that is the one that it has in relation to the Copernicus program. There were what I've seen in the program special sessions on Copernicus, so the link is certainly getting closer. And I think also the awareness of Copernicus as an Earth observation program is something that is largely increasing. But, what? Okay. Allow me to put the first slide on Copernicus. So Copernicus is the European Union's Earth observation program. It's a flagship initiative of several billion euros in the current framework program, and it's very likely to continue in a similar scale in the future. And it is currently one, if not the biggest Earth observation program, single program on Earth, and the European Union is about to become one of the biggest providers of geospatial data worldwide with this program. And it has more and more an impact on industries in Europe. And that is why, of course, there is it gets more and more attention. Of course, the relation to INSPIRE comes, and that is the challenge, that comes from the law. And the law says, and that's the Copernicus regulation, that Copernicus should be compliant with INSPIRE. And for a long time, compliance with INSPIRE, many people were basically saying that is not, that is something that we see. We have the metadata, we have cataloging, web services. All that stuff is usually all INSPIRE compliant already since quite some time. So where is the challenge? The challenge is actually that INSPIRE is an Earth observation program procuring imagery. So that is, I won't go through the details here because otherwise my talk will be too long. But that basically means we produce primarily raster data or coverages, and these pose a very particular problem in the sense that they are covered by INSPIRE, but the INSPIRE coverage is a relatively narrow one in the sense that the solutions that are provided there in some of the annexes, and I have listed them at the bottom of this slide here, they are relatively restrictive. And they are so restrictive that in the real world, if we look to Copernicus, what we find is all kind of stuff, but not a lot that is really INSPIRE A compliant, and B that would show any idea of harmonization. And that in front of the development that we are facing now, we are currently at about 6 terabytes per day of data that are being produced. That will soon, by the end of next year, will be about 9 terabytes per day. There is massive amounts of data that are being pushed out over the web, over platforms, and they need to be taken up. So some people immediately say, so what's the problem? I mean, different grids, you can convert them. You can convert them, but what usually comes when the grid is not the same, and honestly, I would say if these things do not apply, you have more or less the same grid. But if the grid requires a conversion, then it always entails an interpolation of data. It always diminishes the data accuracy. It always is irreversible. These effects are cumulative, so the more interpolation, the more conversions you do, the more of these artifacts you have. And depending on the algorithms that you're using, this could be pretty computer-intense business. So some of your power will be spent there. For one of these, as this was of course this is not rocket science. That is known for quite some time. You find even in the INSPIRE technical guidelines this remarkable sentence in the elevation chapter, which says it would be desirable to use the same geographical grid wherever possible. However, as we have already seen, this is not really happening. So what we were looking at was whom should we get together, who should address that problem. And you have the providers of these data, you have the analysts, the services, the platforms that hold these data. You of course have the users that have their expectations, and you have the standards authorities. So why don't we do a workshop? That is in fact what we have done at the Commission in its facility in Ispra earlier this year in June. And what I will show you next is a bit background of what we found there. So one of the first questions that we were asking is, where are all these different grids in that system? Because it's not Earth observation. If you look at it as a process, it's not just one single block, but it usually starts with the sensor. It has some analysis, and in the end there is the user. And in between, there are at least 2 steps in which you do an interpolation, in which the grid inherently has to change, because the sensor has its own geometry that depends on where it sits, what kind of optics and so on it has. The analysis is something that happens on a certain computer that also has a certain architecture requiring specific grids. And in the end, the users, be it a screen, be it a printed map, whatever it is definitely not exactly the same as what your computer was holding before. So usually also there is a step of interpolation. And now if you have several sensors, this is of course multiplicating. And that would be not so bad as long as these would all live in parallel, but they are not, because of course what we ultimately want to do is we want to connect these. And if now these different analysis grids are different, then we have additional interpolations. That could also be said is not so much of a problem as long as computationally you can deal with it. But one of the consequences of that is that if, for example, if user 2 gets to the data of sensor A, and he goes through that chain, then he makes a conversion from one system into the other. If he would look at the same data, if user 1 would do the same thing with sensor B, he would get different results. If these 2 would merge at this level, depending on which way the data go, you would get slightly different results. The reproducibility goes down. And also, of course, if you do that through several of these platforms or whatever that might be, if you catenate these conversions together, then these effects become steadily bigger. And that is something that could be avoided if you would, at least at that level, work in the same grid. So one of the findings, I would say, in this workshop was that we became more and more aware that we have to make sure that people understand that when we want to change grids or harmonize grids, that eventually it has nothing to do with them. You not necessarily have to ask the sensor manufacturer or the provider of the data to work in a completely different environment, and the user doesn't have to change a lot. But at the level at which you do the analysis, it might be really worth to look into new approaches. So basically a summary of what I've just said. At the sensor level, there is not much chance to do something because these grids cannot be fixed. They are volatile in the meaning of the word, because these things are very mobile. And at the user side, the display formats, there is not really a need to do that because there are so many different purposes. There is probably no chance that all this could work on one single scheme. But in between, there is a layer at which it definitely makes sense. And that is the layer at which we then focused and for which we collected a couple of criteria. I've just listed them here. I will not go through all of them, but we are discussing, of course, questions like equal areadness. We were discussing about coverage, to what extent could gaps or overlaps be allowed? What is the problem if such a system is not a completely coherent, consistent system, if it's several tiled solutions and such? And of course, what are the implications of having cell identification in the use then on high-performance computing? The whole thing has to be seen in front of the steadily evolving environment. Our external drivers in the Copernicus program are that currently the program driven by the Sentinel-2 satellite, which is delivering imagery at a 10-meter resolution, optical imagery. Most of you will have seen that somewhere already. They are finishing now in let's say, probably the next 6 to 8 months, what they call the global reference geometry. And from that point onwards, they will have globally the means to produce imagery at an accuracy of better than 1 to 1.5 of these pixels. So within a 10-meter error budget. And that is something that is unprecedented. Currently, that doesn't exist, not in the free and open market at least. And that will probably lead to a new standard. That will definitely mean that all the old data will need to be reprocessed from the ESA side in Sentinel. That is certainly going to happen. but currently there is no consistent grid that could hold all these data. So currently we would process them into these tiled solution that some of you might know who have worked with these data. And that means that you cannot seamlessly go through the globe in one grid. You will always have to patch things together, and that is definitely something that will largely hinder the analysis of these data. And then at the same time, the EC, to get these data out more smoothly and to have to develop the marketplace, is funding these so-called DIASes as online platforms, the data information and access services. We will see probably 4 or 5 of them coming up also within the next 6 to 9 months. And also there we have the problem that basically we are establishing different dissemination mechanisms, different online platforms, but currently there is no standard that could really allow them to seamlessly cooperate. So the dissemination heterogeneity will increase, and this will of course lead to compatibility problems in whatever is being produced. What can we do about it? Well, as we have tried to get all the stakeholders aboard, we are currently looking into what possible solutions could be. I'm not sure whether anyone has spoken about the discrete global grid systems, the DGGSs, which is a standard that is developed by OGC and which is currently being in that context being heavily discussed also in the context of the data cubes. We will try to implement pilot studies and test beds. Of course, we will not test beds. That is an interesting, just came across this. And what will actually be one of the most important issues here is to facilitate transition and uptake. It will take a lot of marketing because at the level of the analysis, some people would have to change the way in which they currently work. Harmonization always means that you have to give up something to share a solution with someone else, and that is a process that might be a bit more complicated than one initially might think. But, and that's my last sentence, data cubes are something that at least in the Earth observation and raster data coverage world is everywhere now. Anyone who is thinking of a global data cube needs also a global grid. Otherwise, he can have several cubes and he can see how he can combine them, but for a single cube, you need a single grid. And with this, I will finish. Thank you.
Thank you, Peter. Perfectly on time. Do we have any questions from the audience? Yes, there is one, please.
Hello, Stefan Arnold from Statistical Federal Office, and I'm a geographer by education and heart. During a UNGGIM session last year, I heard a presentation from some OGC colleagues who were promoting something like you're asking here for, and it's a globally covered grid approach, but not quadrangle grid cells, but hexagonal grid cells. Have you heard about that?
Yeah, there is.
Do you want to elaborate maybe a bit about it?
I thought, well, that would be another presentation to talk about discrete global grid systems. But discrete global grid systems, I should have left it in there. I had 2 slides in there, but for the presentation, took them out. The basic idea there is that you no longer work on projections, but that you see the globe as what it is, a sphere, and that you do the tessellation, mean the cutting into pieces on the sphere directly. There is many different ways how you can do that. One of the prerequisites is that the polygons you use, of course, need to match, because that only works with quadrangles, that works with triangles, that works with hexagons, with pentagons. There is a limited number of basic shapes with which you can do that. And then you can start on building hierarchies on top of that and indices and all the things that a discrete global grid system requires. So hexagons are very popular in that sense because they very nicely are suited to fit spheres. But they have one of the disadvantages they have, and that's been coming up, is that if you go from one hierarchical level to the next, you completely shift the location. So the center of a cell always becomes, in the next hierarchy, becomes overlapping with many other cells. So you have no no integrity, no inherence in the location of cells, and that is something that makes it more difficult. There are other than triangles, for example, that can be made much easier, but there is also proposals for quadrilateral, meaning based on squares, DGGSs that look very promising. That's the kind of things we look into.
Thanks. We have one more. We need to wait for microphone because of the recording, please.
Did you mean a sphere or an ellipsoid?
Either or.
Because a sphere
Yes.
will be a
One of well, it's one of the decisions to be taken. Yes.
Okay.
But usually it's ellipsoids what is used.
Thank you. Is there another question, maybe? Well, okay. If not, thank you, Peter, once again. And we have again Torsten, but first the colleague, I think. Okay, good.
First,
The floor is yours. Yeah.
Good afternoon, ladies and gentlemen. Thank you for showing up. You may wonder, I'm not Torsten. Let me introduce myself briefly. My name is Markus Braun. I'm one of the managing directors of MOS Computer Grafiksysteme GmbH. And recently we arranged a cooperation with WeTransform and Torsten. So you will hear now about our first project we are going to realize. And maybe I have the best part today because Torsten now is taking over and shows you our ideas. Thank you.
Okay, thanks. That was quick.
Yeah? Okay, so let's first pick the right slides. I'm usually good at talking with different slides as well, so if you want me to just take over your presentations for the next time too, yeah, let's have a session about that too. No, honestly, I thought that was enough presentations for this week. I really enjoy it, the Inspire conference, and I'm thankful that you're still here on Friday afternoon, but yeah, enough is enough, exactly. Lesson learned. Okay, yeah, so basically what I'm not going to do on a Friday afternoon is to do a really deep dive into the technology behind coverages. That was there on the workshops on Monday and Tuesday. There was this masterclass there, for example. But what I would like to talk about is given that we're now starting to look more towards Annex 2 and 3 implementation, or at least some of us, it makes sense to have a look at what's coming up there and how, yeah, given that forward perspective, yeah, we can work together to pick the right solution, so to speak. So very briefly, Markus introduced himself. You probably know me. For the agenda, what we'll do is we'll briefly discuss coverage and vector implementations of different Annex themes, specifically land cover and Inspire. And then we'll have a look at the integration of raster and vector workflows, which effectively we need for some of these. So just to give you an overview, so there's at least 6 themes, probably more, that can be implemented in 2 different ways, meaning that there is a raster or grid-based approach and a purely vector-based approach. Vector-based typically means that you generate a GML file and that's it, whereas the others usually mean you generate a GML file and you have something in addition to that. Yeah. For elevation, there's the extra bonus of also having the TIN approach to encode the elevation effectively. I just explained very briefly already what the different implementations look like, but let's go into a slightly bit more detail by looking at the GML application schemas for the land cover, raster, and vector approaches. So on the left-hand side, we have the raster approach, on the right-hand side, the vector approach. And the main difference is actually the fact that on the vector model, you have a standard geometry in there, and then the land cover observations that actually encode for that particular geometry, for example, a polygon, what is the land cover in there, what's the percentage, and so on. On the raster, it's done a slightly different way. So there are lots of different ways to express the fact that over a given area, you also have a value set. And that value set can, for example, simply be by referencing a data block, which means that in the same file, we actually encode a long list of values similar to coordinates. Or we actually just provide a reference to a file. Or we also have a value array that's a bit more, even closer to something like a coordinate list. Yeah, and so on. So there's different ways basically of how we can implement the raster, but one thing, the few examples that I actually found, most of them used the approach that they would reference a file, like a GeoTIFF file, for example. But in any way, typically what we have to do is, like I said, to provide both. So we have the raster file that contains the values, the observation, and the GML, whereas in the other example we have just the naked GML, more or less. Criteria for making a selection, well, actually, in the cases that we've encountered so far, it boils down to 3, so it's not that complicated. The main question is, what do you already have? I mean, if you have, for example, your land cover in a vector data set, then we just continue to go on with that. If it's a raster coverage, we continue to go on with that. Except if the data analysis that you need to do downstream and the combination would make it much, much easier to use one or the other. And that's one exactly of the use cases that we're looking at later on to see, basically how we can process one to go to the other. And also the question is, of course, of the delivery. In some cases, of course, using a vector format. If you imagine, for example, you currently have a raster for elevation in GeoTIFF, and you imagine that for each of the cells in that GeoTIFF, you actually encode a value in your GML. It's not going to be really compact, and it's not going to be very useful, simply because no software can meaningfully parse that anymore. But for example, if you actually have a data set that you can express nicely as a coverage in the sense of having polygons that have the right size and that are not too small and so on, then the vector representation can be much, much smaller. And I found one example where actually both was available, a GeoTIFF and a GML of the same area. And the size difference was quite substantial. So I zipped both so that it's fair. And then, basically the difference was almost by a factor of 30. So if that plays a role, then obviously, one should also take into account whether it's possible to create such a meaningful vector representation or not. Okay, so given that, the question that I asked myself is, okay, looking at the fact that we do have these both raster and vector implementations of Annex 2 and 3 themes coming up, how can we bring both together? Because I do clearly see use cases where one or the other makes a lot of role. And that, like Markus announced, is basically what we the reason why we started to work together. We traditionally, as the developers of Hail, we have a lot of experience with classical vector data, the stuff that you have in shapefiles and file geodatabases and Oracle and whatnot. Whereas Nova Factory and MOS have a long history of working with remote sensing data to produce all kinds of coverage, rasters, and so on. Also 3D data. So maybe just to quickly give some context again. So the context for the integration that we're doing is the cloud platform that we're developing. Finally, the word cloud had to appear in the session, I think, in each presentation. Where the goal is principally to have one integrated platform that provides consistent services, well managed, and that makes it really easy to basically fulfill your Inspire obligations. And obviously, we could have somewhat started to say, okay, we're trying to deal with all the raster and grid stuff ourselves, but like I said, there is experience with that in Nova Factory, which is a software that's especially used in the German and Austrian area for automated data production, 3D data, like for example CityGML, LOD1 and 2 files and many other things, and also for creating the distribution setup. So if you know that you want to create different types of services from that and deliveries, that all of that can be set up automatically. An important part of that is also the quality assurance, so that you can really provide to a very high standard of quality that's well known, basically lots of different data sets. And one thing that's also important to the users of the software is that it has freely definable data processing workflows, for example, again, to define exactly what kind of analysis and quality assurance you'd like to make. We sat together also with some customers and discussed, okay, what would make sense what should we do to actually bring these systems together? And there's basically 3 use cases that we've identified. The first is, so there are already, in some cases, terabytes of data managed in that system. So it makes sense to basically have a system that sits on top and enables these gigantic amounts of data to be published properly as an Inspire service. So that's the use case 1. transform and publish data that's already managed in the system. The second case, that's more the case where a user doesn't have their own installation. So what they actually know is only, I have this data set and I want it to be published automatically as far as possible, which means that in the back end, again, it will actually be sent to Nova Factory and treated there for processing and for publishing. And then the final one is to actually use all the processing capabilities that the tool provides to perform various kinds of conversions. Yeah, so very briefly to look into these use cases. So for example, one thing is to actually publish a raster layer that is managed in Nova Factory as an Inspire compliant WCS, Web Coverage Service, and Web Map Service. The workflow looks like that. That's a bit of the technical view. But I also wanted to use the opportunity to kind of show you how we approach this, so how we integrate our systems using open APIs. And in that way, also use the ways that the clouds can offer us, to really have open systems to be combined. And basically what happens here is that, first of all, Hail Connect requests what data sets are managed in Nova Factory. Then there are some requests for the files belonging to that data set, which are used to create the WMS later on. And the other operation that's done here is that we trigger the creation of a WCS, of a Web Coverage Service. Part of that is, for example, that the metadata is then also sent out correctly. Then the services are validated, so that's something that always happens in our system. We publish a service, whatever type of it is, it will automatically be validated, for example, using the test suite that GDE has developed. And if all of that went well, then it will also typically be registered in a catalog for usage afterwards. We have a somewhat similar use case for the case where there's not an existing data set already managed in Nova Factory, but rather where it's an entirely new data set. In that case, the process looks similar, though slightly different. So we originally create the data set in Nova Factory, then upload the required resources, and then basically continue as we did before, which means that we publish the relevant services, coverage and map services, and then go again through testing and so on, so that in the end the users have access to the working services. Yeah, so for us, we are more or less, let's say, in the middle of this, and we are going to work on several aspects to make sure that seamless and automated processing and publishing across the different systems really works. That's for me also one of the things that didn't come so much in the cloud session so far, is that we have all these things that can play together compared to if everybody has their own IT infrastructure only. And in that way, we can ensure that there is consistent metadata monitoring. We can also reuse data sets, so stuff that's already managed in existing services doesn't have to be sent somewhere else. What's also important for us is that we are able to support both options. So depending on your applications, you're able to use all those different Inspire implementation options. And that for us is an important step towards adding value beyond Inspire. So it's not just for throwing out data, but really saying, okay, we need the data to be like that so that we can do our own things with that. And that's what we want to enable with this. Yeah. I hope.
Perfect. Thanks,
okay.
Thorsten. Questions? There is one. Michael, please.
Thanks, Thorsten. Very interesting. If I understood correctly, you're already implementing the WCS as well and providing coverages through that. We had some discussions in one of the earlier sessions, I think yesterday or the day before, around the Inspire encodings for coverages that are adding additional attributes above the normal GML coverages as well. Is that creating any issues for you? Would you like to see just the use of normal GML coverages plus the Inspire things and some other schemas like the metadata, or are you perfectly fine with the current encodings?
Well, from our side, with respect to the system setup, that's relatively flexible, though I haven't yet looked into the details of that. So I'm not the coverages expert, unfortunately.
Is this fine, Michael, with you? Answer? Okay, good. Very honest. Okay, is there any other question maybe from the audience? It seems not. Okay, thank you, Torsten.
You're welcome.
Yeah, yeah. Okay, we move to the next presentation, which will be given by Onur Lenk. Onur, please.
Thanks, Vlado. Okay. No. Thank you, Velo. Good afternoon, everybody. Last day, last session, and hopefully I am not in the last speaker, so I have to be quick. I'm the second author. The first author is not here. He didn't attend the conference. Since maybe you are aware of that, Turkey is not a member state to the United European Union. However, in the implementation of the INSPIRE and the other geospatial things, we are in the stage of preparation of our all sort of things, establishing the infrastructure since 2010. For example, since 2015, we have drafted our draft legislative regulation, which is in the synchronization with the INSPIRE directive. For example, this work is an example of the national program in the accession of Turkey to the European Union. What we have here in this work, I would like to outline this in the 3 steps. First, I would like to give information about the challenges of our local administrations in the way of their establishing the infrastructure, geospatial infrastructure. Maybe these are the similar issues everywhere in Europe. Our municipalities must make its own IT investments and train its own staff and provide standard spatial data through standard services for other stakeholders. These are the challenges because they have a limited amount of resources. Hopefully, the INSPIRE directive is giving some principles in order to cope with these difficulties. For example, the INSPIRE directive 7.1 is just saying that the feasibility and cost-benefit considerations shall be taken into account in the development of the INSPIRE implementing rules. So, by adapting this, we are trying, with this work, we are trying to ease their burden in the context of the, for example, sharing the same geospatial modules developed by us, and we are going to give them, and their costs for spending so much money for the geospatial models that I am going to show is going to be diminished as well. Our motivation, as I pointed out, all our small and medium-scale municipalities are the main resources of the spatial data in our country, as maybe you are also the same, most of the country in Europe. And they have deficiency in financial and human resources, which cause delays for establishing appropriate geospatial infrastructure in the country. And we have about 1,365 municipalities. These are ranging from the metropolitan areas to the district municipalities, town municipalities, for example, and the provincial spatial administrations throughout Turkey. And our basic motivation as the Ministry of Environment and Urbanization requires a standardized input and approach from the local governments that covers spatial data users, data producers, financial resources, and policies in order to better use of the resources of spatial data management. This work is maintained and the auspices of the Ministry of Environment. And we just propose a solution to use a cloud system. where we are going to benefit the advantages of the cloud as it provides on-demand self-service, broad network access, and resource pooling, rapid elasticity, measured service. These are very crucial for our metropolitans producing their own geospatial data sets, and to some extent the metadata. And the work has been carried out at municipal level to the national level, utilizing the advantages of the cloud system. And of course, our aim is just to facilitate their work in the extension of in the implementation of INSPIRE principles, because they have to provide interoperability data both to the other institutions in Turkey, and also the Ministry of Environment and Urbanization has to operate all the data and has to make all the data available, operable across the country with the neighbors, for example, Bulgaria, for example, Greece. So we have started a project which is going to be ended after 6 months later, 2018, next year, and on February. The name of this project is it is the technical capacity building project of the local administrations in the umbrella of Ministry of Environment and Urbanization. Our overall objective, well, to enhance the protection of environment of course, it is the EU INSPIRE directive, and also it is in light of the European level environmental protection. And also, we would like to strengthen an institutional and technical legislative framework for all the local administrations in Turkey to cope with in order to be ready, every geospatial data and their associated sort of things for the country. We are conducting this with a consortium having members from Spain, and geospatial modules on cloud systems are developed by our Turkish software guys and headed by the BPR Consulting. It's my consulting company. And of course, we have been supported by the Ministry of Environmental team, which has been given here, these people. And also, we are responsible for about 12 ministries in Turkey, provincial directories of subordinates of the Ministry of Environment and Urbanization, and local administration as well. And we have 5 components of the work. First one is the training and awareness. The other is the spatial data inventory. And third one is the cloud-based geospatial modules that we have been tasked to develop. And also we are developing a process modeling management software for all the local administrations. And we are also preparing some legislative regulations for ministry in order to make available for all the local administrations and also the institutions, governmental institutions, other government institutions in Turkey. We have covered so many things in training and awareness raising. For example, we have done a training need analysis, and we have we have covered and actually we have performed a survey by getting some feedbacks of the local administrations. And in this survey, about 1,890 participants, including among them 651 local administrators. And also we have determined the level of the profile of the local administration society people to be ready, whether they are ready for the INSPIRE implementations or not. So utilizing those informations, we have drafted training programs from basic level to the advanced level, from for the local governments according to the profile of the people, to the central people located in Ankara, and also the data specialists and network specialist program has been drafted to be used, and we are continuously giving those trainings to our personnel. And 4 seminars have been organized, and thanks to Thurston, he has just made a contribution in Antalya to give us a webinar on the hail transformation. And we are just organizing study visits and workshops as well. And in those seminars, we made questionnaires for the people attending those activities. And for example, they're all, they say that they fulfill their needs according to the seminar sessions. And for example, on the right-hand side, they say that seminar enhanced their awareness in OGC, INSPIRE, and spatial data infrastructure activities. These are the photographs. Also, there are Emilio and the Ian, Athena, all participating in these seminars. We are thankful for them. These are the pilot areas that we are conducting our work. The changes to the level of population and the level of their readiness to the INSPIRE activities. And we carried out a data assessment in pilot areas, and we have got those for example, Kayseri, Istanbul municipality, one district attorney in Pendik. For example, it's not an Istanbul metropolitan, but it's a sub-district of Istanbul. 95%, as an example in this table, 95% of the data available, which is where 90% of compatible data, INSPIRE compatible data. The rest of them is not ready for INSPIRE, but it's going to be transformable quality. For example, for the Pendik municipality, the open blue ones are the ready data for INSPIRE, and the red ones here are the available, but it needs to be transferable to the INSPIRE specifications set for by the INSPIRE directive, Annex 1, Annex 2, Annex 3. This is the same situation. Let me explain about cloud-based geospatial models, which is the center of my presentations. We are developing 14 software, geospatial software. As of August 28, we have reached a successfulity of the 52%. Here we would like to provide those modules to the service of the local administrations, as I pointed out, in order to save their costs and the geospatial data production, and also for the process management problems in order to get the burden costs. And this is the main scheme of the cloud system. It's a general outline, which is in center. It has been situated in the Ministry of Environment and Urbanization. All those modules and process modules, and basically municipalities, directorates, and the national stakeholders are using all the softwares through cloud systems. And in between the municipalities, VMS, VFS, VCS services of data has been utilized. Already they are using those sort of things in the data interactions. However, after the completion of our work project, they are going to use all of sort of things through cloud that we are going to give for them. What are those geospatial models? These are the models that you are familiar with, your building information management, 3D topographic map, an application of Article 18. This is a very local application of Turkish legislative and cadastral operation, and an address assessment module, cemetery module, which is very, very popular. They would like to use this for their people living in their cities and the towns, and infrastructure and cloud software are the basic geospatial modules that we have covered of about 52% of availability up to now. Also, we are developing a process modeling management, which is the main idea here is to give the standard process management tools for the local governments in order to produce their geospatial data and their production in a standardized ways. And also, this software is enabling them to execute and improve their process while using the pre-designed schemes that we have produced in this module. The target stakeholders are the same that I have mentioned before. And what we did here is the as-is analysis and gap analysis have been carried out for all the pilot areas that I have showed to you. And also, we have constructed the to-be process modeling after the analysis output. And this software is being carried out in synchronization with the geo modules on the CLAD platform. We have used process management notation, activity open source business process management platform, and we have task assignments and execution processes, and also the model pools have been made ready. Integration with the application software of models are also synchronized within the concept of the process modeling and management tool. As the last component that we carried out, preparation of the legislative documentations for Turkey, for Ministry of Environment and Urbanization. Draft regulation of the use of the cloud system has been already prepared, and the memorandum of understanding between the local administrations and the Ministry of Environment, between Ministry of Environment and the other governmental institutions. We have so many local, actually countrywide national banking agencies, land cadastral operations. We have just prepared a memorandum of understanding, and we are also developing our data exchange strategy. And so in this month, we are going to prepare and give, at the end of the month, implementation plan methodology. They are all in conformance with the INSPIRE principles set forth in the INSPIRE directive. This is our website that we have developed, and you may reach abundant of information there, and also you may contact with us. Thank you very much for your paying attention to my presentation.
Thank you very much, Honor. It's always nice to see how INSPIRE is influencing also non-EU countries. We had a workshop on Tuesday, actually, where we had a lot of nice examples from Ukraine, also Moldova, from Georgia here. So it's really good that INSPIRE is influencing also those countries, and they are on the way for the INSPIRE implementation, also not legally obliged still. Thank you. Are there any questions from the audience? Seems everything was clear. Okay. Thank you very much, Honor.
You're welcome.
Again.
Thank you.
Which brings us to the last presentation about raster data management, which will be given by Peter Baumann. Peter, please, floor is yours.
Thanks a lot. Every PC is a new adventure, and I try to find... Yo, that looks like me.
Okay,
Okay. Coming here. Excellent. Okay. Thank you for bearing with me. This was an exciting week, and so we all maybe are longing for a weekend, but you stay here, and that's excellent. I won't keep you very long. Just want to talk a little bit about data cubes. And wait a moment. Why should we want data cubes? My main point for it is actually service quality. think about all those zillions of files that were served via FTP, have some cumbersome file name conventions. That wasn't really the big success, right? It was just too complicated. We need to have something better. And actually, we have seen something better already. When Google Maps first started on a large scale to offer seamless maps online. That means you don't see a zillion of files, you see one object, the Earth's surface, in Google Maps. What if we extend that into further dimensions? We stack images on top of each other to give image time series. We use elevation and bathymetry as another dimension. So we have something like, say, 3D or 4-dimensional cubes. Okay, why is that good? Because we can do the same thing what we do in flatland. We can zoom and pan, we can analyze, and we can also analyze over time. And as a user, we see a single object. That makes it just so much simpler to deal with it. But this is first of all the data structure. The question is what to do with it. Actually, these are being used already. This is not something that is a new kid on the block. The Earth Survey Initiative is now in its 5th year, and it is establishing data cube analytics on 3-dimensional image time series and 4-dimensional weather data. We use rigorously standards as client-server interfaces, thereby also proving that these services, these definitions indeed scale and can be implemented in a user-friendly and efficient way. Excuse me. On client side, we use Raster as a genuine European data cube technology. And on client side, we like to use US NASA Whirlwind. The largest installation currently is exceeding 700 terabyte of data and is growing towards and across the petabyte frontier still within this year. So what do we have? Mio in Italy, an SME, hosts a Landsat and Sentinel data. That is the 700 terabyte side. Plymouth Marine Laboratory is doing ocean color analysis. National Computational Infrastructure Australia is offering Landsat data. And the European Center for Medium Range Weather Forecast is offering climate data, so 4D data. And this is particularly exciting because what we are planning to do is to open up the 170 petabyte archive of ECMWF over the web via web coverage service. So that's an interesting adventure we are doing. And what we can do already is we can do fusion between data cubes. For example, if you come to our fair booth, I'll be more than happy to show you a live data fusion between NCI Australia and ECMWF in the UK. So in the clients, you might see it like this. So by the way, the 3D Australian data cube that is already available is running Raster. You may have seen presentations where Australia is implementing the Open Data Cube, and from all that I know, this is just 2D up to now. And on a limited area, derived product, something that is derived on the fly, again including time series analysis, surface temperature, and something like river discharge in the climate area. We also have done such a thing with, thanks a lot, with a German remote sensing data center. AVHRR images, 10,000 images put into one data cube. Look at the bottom left, the year when we did this. So we have done that since some time, and you can get the cutouts, you can do time series analysis, and they initially said, okay, spatial analysis is fast, but temporal analysis is slow. We looked into it and we found out that they had organized data exactly traditionally flat slices. Of course, time series analysis is slow. We told them, hey, use the capability of Raster to organize data into 3-dimensional partitions. They reorganized, and suddenly spatial and temporal analysis went at the same speed. So that gets me to this funny name, Raster, which stands for Raster Data Manager. We like to do queries. We come from a database background, and we feel that a query language gives us so much flexibility. You send 3 lines of code, and the server with some magic does it somehow, including all these optimizations. And so we have some architecture behind, which is scalable. And actually, you can use the same thing not only for Earth data, but also we have done human brain images, we have done cosmological simulations. It's all the same thing. It's multidimensional data cube. So meantime, the whole thing is in operational use since quite some time. Blueprint for big data cube standards. You may or may not have heard about the extension of SQL with multidimensional arrays that is crafted along the Rasterman language. And so naturally, we also became reference implementation. The architecture is like this. Rasterman server is the central workhorse, which is multi-parallel, and it can take the data from a PostgreSQL database, Oracle database, or whatever. We also have our own storage manager, which is about a factor of 2 faster, and we also can tap into external archives without importing data. So we just read them on demand, evaluate the query, users don't see any difference, and return the results. The geosemantics comes in via an extra layer that knows about coordinates, space-time, and about regular and irregular grids. So that is the overall architecture. And for processing, actually, we use a very dynamic paradigm. We don't have something as static as map-reduce, so first map, then reduce, and nothing else. But actually, we look at each incoming query individually and split it on demand. So for example, data set A, we can do the yellow part immediately. The orange part, we send that to a buddy in the cloud that has the data. The same principle we can apply to a data center. We send a sub-request to another data center, or even up to a satellite. This is a project that recently has been granted, where we will install Rasterman on board a satellite and integrate it into this cloud, into a federation. We have split such queries over more than 1,000 cloud nodes, so that is a good way of speeding up, of enhancing performance. If you look at that, we actually have the standards in place. That's what I said. We have data cube standards. The OGC Web Coverage Processing Service actually is a data cube analytics language. And here is an example where the computer graphics specialist told us, did you know if you take a PNG image and put elevation into the transparency channel, then WebGL can do some three-dimensional rendering? Cool, we said. Let's do that. So we take a satellite image and a DEM. We put arbitrarily some bands into red, green, blue, and the alpha channel contains the elevation model, which needs to be scaled so that we adjust resolution. The result gets shipped as a PNG, and in the background you see a screenshot of such a terrain draping that has been done through a query. Of course, it doesn't have to be height that you put in there. You can put disease spread, population density, whatever, to generate diagrams. In this case, we have used data from the British Geological Survey. We collaborated with them into that. By the way, after that, interesting enough, BGS became editor of the coverage of the WCS specification. So they had an excellent training, and so therefore the specification in Inspire is really written in a crisp way. You can even emulate a web map service. So you take an orthophoto with this, the $P. This was an old one, black and white, so we had to multiply it into red, green, blue. Therefore, multiplication with 1, 1, 1. We overlaid with water lines, with water areas, all colored according to the German color schemes. And then we put on top of that an elevation model where we have a classification according to heights and a color scheme. The whole thing again shipped as a single PNG, and you see it and you can work on it like with any WMS. But sadly, nobody wants to see that. So we like database languages, but nobody else likes that, or most people don't like it. Actually, people would like to have their clients. And so we put a lot of effort to hide that, to actually use well-known tools as front ends. So for map navigation, you might want to use open layers, Virtual Globe, Whirlwind or Cesium. WebGIS, use QGIS or whatever. For analysis, maybe you want to use Python. Our friend is the standards API, because actually any client that adheres to the standard specifications that can generate such requests can tap into the data cubes and can extract this information. And so we don't build the clients ourselves. Yes, we have one, but others have done much more fancy stuff. And so we like this coupling. Okay, I don't know how much time is left.
4 minutes.
Okay, thank you. So let's wrap up. Analysis-ready data is a new paradigm that attempts to provide data right in the server in a way that they can be accessed and analyzed readily. Okay, that means some extra effort, homogenizing data, but then you get something like a data cube that is much easier to handle conceptually and which can be supported by rich functionality. So the tools that allow to create a data cube actually do that work that earlier all the users had to do. Fortunately, we have standards available that are practice proven into the petascale, and fortunately, they are almost homogeneous. In OGC and ISO they are. In Spire, we are working on that because an earlier specification that was done back in the coverages, there was some own creativity that deviates from OGC. But Jordi Escriu, and with a little help of mine, is trying to re-homogenize that. By the way, we have conformance tests that test down to pixel level whether a server is doing the right thing. So we can achieve true interoperability here on semantic level. We also talked a little bit about Rasterman as an engine that actually has pioneered data cubes, or as we like to call it in database research, an array database system. If you want to look into the source code or download and run it, rasterman.org contains that. Plus lots of tutorials, also webinars are available. And once again, I believe I should not use your time longer as weekend is coming. So thanks a lot for bearing with me, and I'm happy to take any question. Thank you.
Thank you, Peter. So, okay, we can open the floor for questions. Is there anyone? Or not? Seems that it was perfectly clear. But people can still reach you on the booth, so it's still open to...
Yes.
If someone is interested,
we are there.
You can... Yeah, okay.
So please come along, and I can show you some live demos that work on multidimensional data.
Good. Okay, thank you, Peter, once again.
Okay. Thank you.
Okay, so we still have some time, but I think we can actually close this session a little bit earlier, as I already announced, because there is a closing session right now in 3:30. There will be no break, so you are all more than welcome to go to the auditorium for the closing session of this Inspire conference. Thank once again to all presenters, and thank to all of you to be here with us.